All right, our next lesson involves proofs with the addition and subtraction postulates. It can be done with angles, but we're going to be focusing on adding segments. And so let's go ahead and look at our first example to kind of explain the addition postulate. All right, so first of all, what is a postulate? It's just an assumed truth. Like, don't get overwhelmed by that word. Okay, so it says if congruent segments are added to other congruent segments, then the sums are congruent. So let's look at how this occurs. So given, if we are given that AB is congruent to FG, and we're given that BC is congruent to EF, then the conclusion that makes sense is that AC is congruent to EG. The full length of AC is congruent to the full length of FG. So let's just kind of do that numerically to confirm that we believe that. If AB is 5, that means FG is 5, right? And if BC is 10, well, that means EF is 10. And then guess what? That means that this segment is equal to 15. And this segment is equal to 15 when we put them together. All right, so then how can we make this easier? Because sometimes I know the alphabet part of it gets a little crazy. I want you to think about when you do addition problems like this, 3 plus 5, kind of like that, and you get 8. Okay, so we're doing vertical addition. Let me just erase that. It's a little bit messy. And start with what we're actually playing with. So if I take that first statement in the given, AB is congruent to FG, and then underneath it, line up the second statement, BC is congruent to EF, and then do almost like I'm doing equation solving, I do an addition symbol. Then I want you to see what happens and what can help you. Notice how there is a B here and a B here. I'm going to cross those out and look what I'm left with. I'm left with segment AC. Okay. And then in the next one, here is an F, here is an F. I'm going to cross those out. I'm left with segment EG. And notice how that matches our conclusion right here. So that could help you with that process if you're struggling to visualize it. All right. So now let's put together a proof with that. So take a moment, draw your table, use your straight edge. Remember, neatness counts. And start to mark the things that are congruent. Okay, so I'm going to go ahead and do the same. All right, so let's take a moment to look at our givens. The first one says segment GH is congruent to LM. All right, GH is congruent to LM. When I look at the triangles that are there, and I can clearly see there's just 2 triangles, that not only have I marked it on my picture, so a check mark, I can see that that's a set of sides. Okay, next one. HK is congruent to MJ. Double marks. Okay, so I have marked it on my picture, and it is also a set of congruent sides. So as of right now, I have done this. GH is congruent to LM, and HK is congruent to MJ. Now, they're not, the purpose of this is to practice the addition postulate. So let's see what they give us. So the last set they give us is from G to J. So just from here to here is congruent to L to K from here to here. So this is congruent to that, but that's not a set of sides. So I have marked it, but it is not a set of sides. The side for each triangle, so I'm going to go and outline my triangles to kind of demonstrate again what's happening. We have GHK and we have LMJ. And when I outline those two triangles, do you guys see that there is essentially a shared segment? It's not a shared side, it's a shared segment. So first of all, in my given, I still need to write down GJ is congruent to LK. Okay, statement 2. I need the full side of each triangle. So to get that side, I need to add in JK. So guess what? It belongs to both triangles. I'm going to put an X on it. If I put an X on it, I'm using the reflexive property. And I'm just going to put JK is congruent to JK. Okay, so now I'm ready to get my final set of sides. And my final set of sides will happen when I add, and I don't know how to do this without drawing so much stuff on here. I have to add this piece to this piece, right? And I have to add this piece to this piece to get the full set of sides. All right, so here we go. Step 3. So I'm going to go ahead and look at what I have up here. I have GJ, and I'm going to add to that JK. The J's cancel out, and I have GK. The other side is going to be, I go back up to this given right here. Can you see where I'm tapping? LK. And then I have JK, and these are going to cancel out. So GK is congruent to LJ. And let's just confirm that. GK, that's the yellow side. LJ, that's the blue side. So by using the addition postulate, I now have my third set of sides. And so to finish this proof off, just go back up to the picture. Do we now have side, side, side? Yes, we do. There's no angles involved in this proof. So by side, 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 triangle GHK is congruent to triangle LMJ. All right, so that's an example of the addition postulate. Let's turn the page, and here we go for our subtraction postulate. And so once again, you can always just explain what you're doing. So an explanation of what's happening is if congruent segments are subtracted from congruent segments, then the difference of those segments are also congruent, okay? Let's look here what we have. So we are given that MP is congruent to NQ. And so if we take away NP from both of them, then we will be left with MN is congruent to PQ. Okay, let's go ahead and kind of show that off to the side again. You can do it vertically or horizontally, either way. So I have the original statement right here, the given. I have MP is congruent to NQ. My reflexive statement is going to be I put the X there for reflexive, is going to be NP is congruent to NP. Now we're going to subtract that reflexive piece. So notice here, the P's are going to cancel, the N's are going to cancel, and we are left with our two congruent segments, which are MN congruent to PQ. This is supposed to be a Q, my bad. Okay, hopefully you caught that and you said, oh, Miss Rob, you wrote a G. What were you thinking? Okay, so now let's go to our example problem. This proof is going to have quite a few steps, so please be cautious that you're leaving yourself enough space to write. If you are a big writer, please grab some extra paper and tape it in, tape it on, do what you have to do. Okay, so the first question I'm going to ask you guys before we even dive in too much to the given and this and that is I want you to stare at that picture. How many triangles do you see? All right. So I am going to assume that people see this triangle over here and this triangle over there, right? And then you might see this triangle here and this triangle here. And none of those triangles are overlapping. But did anybody see this triangle and this triangle? All right, so just there are 6 triangles there. So something to be aware of. So when you have a more complicated picture like this, it is almost to your benefit to start with what your goal is. Remember, the prove is your goal. What is my goal? Okay, so our goal is to prove AFB is congruent to CED. Okay, there it is. So now what that helps us do is when we're doing our givens on the picture, now we can kind of see how they're related to the triangles our goal is at. So let's look at our first given. We have AB congruent to CD. I'm going to mark it with tick marks. AB congruent to CD. And whoa, slow down, cowboy. That is a side. All right. Now I'm going to mark BF perpendicular to AC. I'm going to use a highlighter to make sure you guys see what I see. And I'm going to erase it. Okay. So BF is perpendicular to AC. Okay, so there's our perpendicular lines, but where is the angle from perpendicular lines? From that, I want to mark this angle right here with a 90-degree angle. So perpendicular gives me 90-degree angles, which means I might be going towards an angle, or I might be going towards HL, which means I might need right triangles if I'm going towards HL. So we'll figure that out in a minute. All right, I'm going to erase those highlighted marks so that way they don't get in our way. But notice now when we go to do the other set, it's DE in this other triangle is perpendicular to that full diagonal again. So this is our other right angle. Okay. The last thing they give us, and I'm going to use my highlighter to kind of help me see what's going on here, is we have AE, uh-oh, that goes past the side of the triangle, congruent to CF. All right. I only need from CE and AF in this proof, right? That's my set of sides that are going to help me make the triangle. So what I'm going to need to do is remove that middle overlap piece. Okay, so we have a lot to do in this proof because right now we have a single set of sides, and that's it. Up here, this is the only thing we have right now. And we also have to decide how we're proving these triangles congruent. So let's just take a moment, set everything up. Take a deep breath. And actually just set up your table because I want to show you another strategy for working with your givens if this is getting too overwhelming. All right, statement, reasons, given. Now we have 4 different givens, and that's a lot. So maybe let's process them in smaller groups. You could actually list each one separately and do 4 steps for the given, but I'm going to put them in pairs. So I'm going to do AB is congruent to CD because that was a set of sides. And then I'm going to do AE is congruent to CF. Okay. All right. And I'm going to focus on using those 2 givens first. All right. Now, if I want to have AF congruent to EC, I've got to subtract that. So for next thing I need to do before I can subtract it, I need to put it in my proof. So that's going to be the reflexive property. Okay. And so I'm going to say FE is congruent to FE. The order of the letters doesn't matter. I was just reading bottom up, left to right. Okay. And now I'm going to do subtraction. All right, so I usually choose to rewrite the subtraction piece to make sure I know what I'm doing. I'm going to do it horizontally to make it a little bit easier. So my first subtraction problem, and just don't get upset here, is this guy subtract that guy, right? They were actually the yellow line. I should undo that. But here we go. I'm going to do AE, which is too long, subtract FE. And then I'm going to do CF subtract FE. And I can put that in between. So I am doing exactly what the postulate says. I'm taking congruent segments that are overlapping and subtracting them so I can get additional congruent segments. So the E's will cancel, leaving me with AF. And then the F's will cancel, leaving me with CE. And that is the subtraction postulate. So before we go farther, make sure you're happy with that. Okay. AF is congruent to CE. All right, so now let's figure out how we're proving these triangles congruent. Are we going to be doing side, angle? Is that allowed? Not so much. So what's special about these right triangles is that we can then use hypotenuse, leg, to prove them. So we're not going to be using the right angles as angles. We're going to be using hypotenuse leg, which means we need to say that we have right angles, and that means we have right triangles. So I still have the rest of the given to put in. So let me go to statement 4. And statement 4 is more given. So the perpendicular lines are BF is perpendicular to AC. And DE is perpendicular to AC. They will not give you information that you're not going to use. Okay. So I am going to go just forward with the easiest method of making sure I don't make any mistakes. And I'm going to say perpendicular lines form congruent right angles. And my right angles are angle AFB is congruent to CED, angle CED. Pause the video as needed if I'm talking too fast or you need to pause and write things down or look back and make sense of what you just did. So something that's helpful is, do you see how there's a perpendicular symbol here and a perpendicular symbol here and a perpendicular symbol here? If I have perpendicular given to me, I have to use perpendicular on the statement side because there's a conclusion to be made. Okay, now since we're going towards HL, we need to say that triangle AFB and triangle CED are right triangles. And that's because a right triangle contains a right angle. And then you are ready to say HL and conclude this proof. Triangle AFB is congruent to triangle CED. All right, so pause and reflect and check. Do I understand the subtraction postulate? Do I understand the addition postulate? Am I ready to add that into my 3x5 cards to make sure I can add those into my proofs? All right, thanks guys. We'll see you on Friday.